And yeah, welcome to the March 2021 Kubernetes Bangalore meetup. So for those of you who are new, we do this meetup every month. We used to do, this time we are back with a theme-based meetup. We used to do it earlier before the pandemic struck, but this time we are doing a theme-based meetup, and the theme for today's meetup is Kubernetes Operators, right? So for those of you who are also not connected to us on Twitter, we are on Twitter with KTSBLR, the handle. You can connect with us there. And most of us hang around in the Kubernetes Slack as well. So I would request those of you who haven't joined to join the Kubernetes Slack, right? And I would also like to thank our first speaker before I introduce her. She's doing it from the US. She's stayed up very late for us. So yes, we expect that many amount of questions and energy from the audience as well. So yes, a few points before we start. If you have any questions or something to say, you can use the chat, the Zoom chat. The speakers will answer your question based on their preferences or at the end of the talk, right? And also, please maintain decency while commenting in the chat section, and provide constructive criticism and comment with respect in the chat, right? So without wasting more time, let's get to introducing our first speaker for today, who would be talking to us about, she would be giving us an introduction to operators, what they are, right? So our first speaker for today is Varsha Prasad. So she's a software engineer working at Red Hat. She has been active around the open source circles and been contributing to multiple Kubernetes related projects. She's a member of various Kubernetes-sigs and has also been contributing to OpenShift. Right. So she's also one of the maintainers of Operator SDK, which is a framework. For those of you who don't know, Operator SDK is an awesome framework for building operators. And today Varsha is going to introduce us to operators. So over to you, Varsha.
Hi, everyone. Let me share my screen. So are you all able to see my screen?
Yes. Yes, Varsha.
Okay. Hi, everyone. Good morning / good afternoon. I'm really happy to be here and excited to meet you all. So let's get started. As you all know, today's topic is introduction to operators. So before getting into operators, let me quickly introduce myself. Who am I? I'm Varsha. I'm a software engineer at Red Hat, and I have been contributing to Kubernetes projects for around a year. And I'm a maintainer of Operator SDK. So I promise I won't basically tell you more about SDK. I'll talk in general about operators. So enough about myself. Let's get into what operators are. So this operator word has become pretty famous. Everyone is using it. It's all around. So it was coined by CoreOS, a little bit of history here. And then CoreOS was bought by Red Hat. And then I'll stop it there. Now, let's get into what these operators are. But before getting into what operators are, we should be knowing what Kubernetes is. And since this is a Kubernetes meetup, I'm pretty sure all of you are aware of what Kubernetes is. But let me quickly give a very brief overview on it. And let me not spend much time here. So what is Kubernetes? Kubernetes is a containerized, is a platform to manage containerized workloads and services. So basically it helps you to manage the life cycle of a containerized application. So it helps you to scale up, scale down. It takes care of your network workloads. It takes care of your distributed systems, which are entirely present on a containerized platform. So it's all about containers from starting to end. Now, a little bit of history here. Name originates from the Greek meaning called pilot, but okay, let's skip all that. So it was open sourced by Google in 2014. It was based on a Google internal project named War. So Why is Kubernetes liked by many? There are 101 reasons for this, and definitely I'll not get into all of these 101 reasons because sometimes it's advantageous, sometimes it's disadvantageous, and there are various things to weigh whether to use Kubernetes or not. Now, the two most important things which I would like to mention here are the scalability of workloads, which Kubernetes provides, and the separation of workloads. And this is something which is provided due to the fact that we are using containers. And Kubernetes is basically an orchestration service for those containers. Now, apart from all these are the generic advantages, disadvantages, and all those stuff. As a user of Kubernetes, what is it which I get? Now, there are two things which I get from here. One is the ability to support native stable resources. We will talk more about what resources are, what are native stable resources, and all those stuff. And second most important thing is that it helps us to extend the Kubernetes API through something known as custom resources. Now, custom resources is something which we will talk in depth because operators are entirely based on custom resources. So before getting into the custom resources stuff, let me get into the heart of operators. So operators are majorly comprised of controllers. Now Kubernetes is all about automation, and we have controllers here which automate our tasks. Now let us step back a little bit because I'll go through this slowly because this is one of the most important topic. Now, what are these Kubernetes controllers? They help us in automation. But when do we need automation? There are two situations when we need automation. One, when we have a set of repetitive tasks. Second, when we know what these tasks are and we know when to perform these tasks. So that's when we can translate whatever knowledge we have into a software source code. Now, controllers do the same. So consider a case where you have a cluster, you have a resource. I'll talk in complete generic terms. I'll not specify any Kubernetes resources. So say we have an X object on a cluster. Now I know that the desired state of this X object is so and so. I want the X object to have, say, 4 replicas. I want the storage in X object to say this much. And I have all the specifics of what I want the object to be, or the state in which I want the object to be in. Now, there are various changes in the distributed systems because distributed system is made to change based on the environment so as to adapt itself. Now, there are various changes happening. Now, do I even need to spend human resource or even take an effort to actually look at the state of my object? And whenever there is a change, make a set of changes to make sure it reaches the desired state. Now, in simple terms, say I have defined the object to have a replica count of 4. Now, let's not look into what has happened, but something happened and one of my pod died. Now, the replica count of the object is just 3. Now we know what to do. We know that we have to just go and apply a YAML manifest. We know the steps we have to take. Now, when we know what we have to do, and when we know when we have to do what, then why do we even spend time or the human resource in just seeing or observing the state of the cluster and taking that action? We can use controllers, and that is what Kubernetes controllers do. So Kubernetes controller is nothing but a non-terminating loop that regulates the state of the system. You can think of this as a state machine where you define a desired state and you have a current state. And whenever there are changes in the current state, you want to make sure that somehow you reach the desired state. And controllers do the same. Now, whenever you look into controllers, there are 3 important things which will come or which you will read about. So the first thing which controllers do is basically controllers observe the state of the cluster. So please stop me anytime whenever you feel that I'm going fast or That is something which you're not able to understand. Because I'll repeat this again. This is a very important topic to understand what operators are. So how do Kubernetes controllers behave or take the required action? So the first thing which they do is they observe the state in which the cluster is in. Then they find the diff. Now, what do? What is the diff which they calculate? Obviously, the diff is between the desired state, which you have specified, and the current state, which you are observing. And once you know what the diff is, then the task is easy. You have to act on it. Now, what do we have to act on it? It's the job of the Kubernetes controller. So this act is something which is specified. For example, it's creating a resource, it's deleting a resource, or it's upgrading a resource to another version. And all these acts are basically specified for you upstream. So by upstream, I mean something which is present in the Kubernetes resources or something which is provided to us by Kubernetes. And by downstream, I mean something which we have adapted to it. So this is the terminology which is like generally used. When you listen to people say about upstream, it's usually the one which is provided by the Kubernetes itself. Now, these are the three things as I mentioned right now, which you will, when you start looking into controllers, which will come into picture, which is observe, diff, and act. Now that we know what controllers are, I know that most of the people who would have worked with Kubernetes should be aware of Kubernetes objects or Kubernetes resources. Now, what are these resources? So this resource, a Kubernetes resource, is an endpoint to the Kubernetes API, which stores a collection of objects. Now, these objects, in simple terms, help us interact with what is present inside the cluster and help us to maintain the application effectively. So for example, pods. Pods are something which we will keep hearing in the Kubernetes world. So what are pods? Pods are the smallest deployable objects which are present. Now they can be a group of containers. Now what are deployments? Using deployments, you can manage pods and replica sets. Similarly, you have services, you have config maps, you have secrets, and all those things are something which is provided by Kubernetes to you. So you don't have to do anything. In the sense, you have a particular schema which is provided to you by Kubernetes, and you have all these specific APIs. So for example, Kubernetes makes us easy to look at a particular object, to find the state of a particular object, to list these particular objects through the APIs, which are provided to us. Now, let me quickly go through what a YAML manifest of a resource looks like. Not exactly resource, we usually call it a Kubernetes object. Now, for example, here I'm taking a deployment, and this is one of the major part, which is GVK. And whenever you get into any of the Kubernetes repos, you will listen to this word GVK pretty often. So GVK basically refers to group, version, and kind. And group, version, and kind is something with which we uniquely identify an object which is present inside the cluster. Followed by which we have the metadata. In the metadata, we have the name, we have labels, you may have annotations to your objects, so on and so forth. And then you have spec. Now, as I was mentioning about the desirable state, spec is where you specify the desirable state of the resource. So here, for example, I have the replica count to be specified to be 3. This means my desired state is that this deployment must have 3 replicas. And there is another part here, which I haven't shown, which is obviously the status. Now, what does status do? Status tells us the current state the object is in. So as I said, status is the current state and spec is the desired state. And this is where we need to calculate the diff from. Now, this is about the Kubernetes resource, which Kubernetes is providing to us. Now, what if I have a need to create an object and that object should do something which I want? So I want an object where I want the spec to have something like, say, a particular annotation, or I want the spec to have an image pull policy. or I want the spec to have any details which I want. I want it to be customized, and I want it to handle it the same way and have the same I want to do the same use of Kubernetes APIs. Now, what do I do? By that, I mean, I'll make it clear. So I have a custom resource. I want to be able to get the custom resource, list the custom resource, similar to how you will list a deployment or a pod. Now, what do I do? Do I write API server on my own after writing an object? No, I will not do that. That's a pretty difficult task. And if that was the case, then Kubernetes would not be so famous. So there is a solution. And the solution is having custom resources. Now, custom resources are the resources which the users define. They extend the Kubernetes API. This means that when I have a custom resource, I can handle the custom resource similar to how I handle a deployment or a native Kubernetes resource. Now, how do I define the custom resource? Through custom resource definition. So CRDs and CRs are one of the major important aspects which constitute the operator. So let's take an example of what a custom resource looks like. Now, this is a YAML manifest, which you can actually apply on a cluster. And here, if you can see, the kind is Grafana. Now, a Grafana is a very good visualization tool. It helps us to collect the data. It has so many good things. It helps seamless integration with Prometheus, so on and so forth. I'll not get into Grafana, but Kubernetes doesn't provide me with Grafana, but I want to have an instance of Grafana. What do? I create a custom resource. Now, you will be able to map the custom resource and the native resource here, because the custom resource is again going to have a group version kind, which is the GVK. It's going to have the metadata, and it's also going to have the spec. Now, if you look deep into this, now here, if you see in the spec, I have defined a config. I've defined an ingress, or I've defined an ingress for enabling traffic, and then I have security, auth, everything defined. Now, how do I tell the Kubernetes server that I have a custom resource which has this particular spec? Now, for deployments and pods, the server already knows that, okay, deployment is going to have a spec field which has replica name in it, which has a particular key value in it. Now, how does the Kubernetes server know that, okay, there is something known as Grafana object coming in? So for that, we need custom resource definition. As the name suggests, custom resource definition applies the custom resource. So for example, this is the custom resource definition here. And so this is a different example that was for Grafana, and this is for a cron job kind of custom resource. So when you create an instance of a custom resource definition, you get a custom resource. Now, what is the CRD? The CRD is basically the template which you will tell to the server, which you will apply, and you will tell the server that, okay, I'm going to have a custom object whose name is cron tabs or cron tab. And when this object is created, this is the spec which it could be having. So it will be having a storage version, it will be having a schema and all those things. And this particular type of object will have this particular property of the type string, int, or whatever we want. So whenever you create a custom resource, you first apply a custom resource definition in the cluster. This is because you want to tell the Kubernetes API server that this is the format of the resource. This is the template of the resource which you will be getting next. So finally, let's get into the actual topic, what operators are. Now, when you immediately go and search what operators, you will get all sorts of proper definitions, but let me give a very simple definition as of now. And then we'll break down each of this definition and get deep into what operators do and all those things. But what are operators? Now that we know what controllers are, what a custom resource is, operators are nothing but they represent the human operational knowledge in software to reliably manage an application. Now, I didn't want to skip providing the official definition here. So this is the official definition. It helps us to package, deploy, and manage a Kubernetes native application. Now let's break down both the definitions which I have mentioned and look deep into what operators are. Let's take an example. This is a stateless application. Now in a stateless application, things are pretty easy. You have two pods running here. You have specified the logic or the application image where you have all the software packaged and you're telling this pod that, okay, run this particular application. Now things are pretty easy because these pods are running inside the Kubernetes cluster. There is no storage, there is nothing. They are just particular pods which are running the application. Now in this case, life is easy. Why? Because you have Kubernetes to manage your cluster, your application. What you would have to do in case of scaling up, scaling down, or updates, or rollback services, anything is being taken care by Kubernetes because you have a desired state. So here, say I will have a desired state specified where I want the replica count of the pod to be say 4. And my controller loop will come into action. My Kubernetes loop will see, okay, there are just 2 replicas. Now what do? I increase the count. Let me spawn 2 more replicas. And say when there is an update, when there's an updation in version, what do I have to do? I have to restart the pods so that the application gets reloaded. So things like that are already defined. And this is pretty easy because you have a particular set of tasks and you have Kubernetes controller taking care of everything. Now, what happens in the case of a stateful application? And by stateful application, I mean something which has a database. Now, as an example, let's consider the same app, but for difference, this app has a database attached to it, and everything is running on a Kubernetes cluster. Now, what happens in this case? What do you do when you have to scale up or scale down? Things aren't pretty easy. Why? Because the process of scaling up or scaling down a SQL server is pretty different. And it's different for a particular kind of database. It may be different for SQL, it may be different for Postgres, or things like that. Major reason why it is different is because each of the databases here are different. You don't have the same data inside each of the database. You have different data here. Each of them have their own state and have their own identity. So you have to authenticate each of them. And again, you need to have a logic to synchronize each of these databases. And this logic, as I said, differs for different things. And most importantly, you can't just scale up and scale down. You can't just add a pod or you can just spawn a database server because this has a different order. When you spawn a database server, when you include a different copy into the system, you need to make changes to the other objects also. Now, when there is so much into it, what's the use of having automation system like Kubernetes when Kubernetes can't do all this? Because you can't have the Kubernetes controller loop can't take care of all these custom changes which happen here. And when you don't provide an automation to me, why should I use Kubernetes? I can just go and deploy this on a bare metal server and take care of myself, because anyway, I have to spend the human resource to look at each one of these and make changes. Now, this is where operators come into action, because operators replace the human knowledge with a software code, and they try to repeat the manual tasks. And what are these manual tasks? The manual tasks are what I had mentioned before, where we have a particular process, custom process to upgrade each of these applications. And this is basically packaged into a particular program. Now, let's come into what operators do. So operators look at a custom resource. We know what a custom resource is right now. They track the change of events. This is the observe cycle, which I had mentioned in the controller loop. And then they try to reconcile and make sure to adjust the current state to reach the desired state. And the main difference here is that the logic which I had mentioned in Kubernetes controllers was pretty generic. But here we have something known as custom controllers, because the logic here is basically domain specific. It is an app specific logic which you yourself write into the controller to make sure it reconciles to the desired state. Now, what is inside a controller? So this is actually a topic by itself. Are you able to see the right this thing? Yeah. So what is inside a controller? So this is a very in-depth topic, and you actually need not know what is actually inside a controller, because there are various clients like controller runtime and client.go which help you scaffold and do all the internals. But I will give a brief overview about this, and you will anyway be able to understand more about this in depth when you write a reconciler. So what usually happens in a controller, as I said, are the three important tasks: observe, track the changes, calculate the diff, and act on those. So how do we do that? We basically have a reflector, and this reflector lists and watches the resource which we get from a Kubernetes API. So we basically register a watch to watch a particular resource. Now what happens after this is you have an informer here. As the name suggests, informer is going to inform about the changes which are happening to the objects which are present here. Now in case of operators, these objects are custom resources. And once you have an informer, the informer is going to send these particular objects to a handler. Now, before sending it to the handler, it also adds these objects through a thread safe cache, because we are going to look at the cache to see the desired state. The desired state is stored in the cache to make up the lookup faster. And this handler is going to handle the objects, as the name suggests. Now, how does it handle the object? It sends it to a thread safe work queue. And what happens after the work queue, which is the process item, is the reconciler part. And this process item, which is mentioned here in the yellow box, is what the custom logic which you write, is what the custom logic, which is the human operational knowledge, which is translated into a software code. So whenever there is a change, you have these informers which are looking at the objects. They send it to a thread safe store, and they send it to handlers. Handler put them into the work queue to just make sure that a particular object is reconciled once in a particular cycle. And basically, you even look at the cache here to know what is the current state of the object and what is the desired state of the object. And this reconciliation logic is the one which is going to do the diff, make sure that, okay, these are the changes which are required to be done on the object, and perform the changes. So this is what an operator is. So an operator is something which is going to act on a custom resource. And what it is going to act, that is the logic which you have provided in the custom controller. So a custom resource less custom controller results in giving you an operator. So operators are useful. And I think the past 28 minutes of my talk are all about how operators are useful and how good it is. But the thing here is operators aren't a solution to everything. So I don't want to end this talk just by saying that use operators and life would be easy. Because there are cases where you don't have to use operators. There are cases when automation is actually bad. You don't have to write a very heavy software just to automate something which is pretty simple, which you can do through a bash script. So that's why operators are a solution for everything. So when do you use an operator? So you generally use an operator when you use a declarative API. And by declarative API, I mean there is something where you declare the desired state of the system or of the object or of the resource, whatever it is. It is just the desired state which you have in mind, which you declare. Second thing of using an operator, why you should use an operator or when you should use an operator, is when you have the business logic. So when you have something pretty simple, like scaling up and scaling down, then why do you even use an operator? You can have the custom controller, Kubernetes controller, and use the Kubernetes objects itself. You need not have, you need not write a reconciler logic, which is pretty heavy when you have very simple tasks to do. So when you don't have a business logic, you don't need an operator itself. You don't need a custom controller. A normal Kubernetes controller serves its purpose. And third is when you need a top level support from kubectl. Now, when you use an operator and when you create a custom resource, you can easily interact with the custom resource through kubectl commands. And kubectl helps you to interact with the Kubernetes API server, as I said, to list, get, or to watch the resource, so on and so forth. But when you need such an interaction, operator is going to help you. But the most important part here is when you don't have a custom resource and when there is a situation where you have to use just the native Kubernetes resources, then you don't actually need an operator. You must be fine with the Kubernetes controller. So when the native Kubernetes capabilities are sufficient, then you don't need an operator. You don't need to have an operator or the operator logic present here to basically make your project heavy. So next is about writing an operators, and I think there is more about writing an operators in the next session, because there are various frameworks like KubeBuilder, SDK, Operator SDK, meta controller, so on and so forth. I will not go much into it, but I think this is all I have for operators. I'll be happy to answer any of the questions.
Yes, folks, you can go ahead and raise your hand if you want to speak, or just post it in the comments. So one of the questions that went up in the chat and everything was about using OLM and Cube Builder together. So
is there a specific question, or I can talk about Operator Lifecycle Manager in general?
I think you can explain what OLM is and if it can be used with Cube Builder at all.
Definitely, that's a very great question. So OLM represents Operator Lifecycle Manager, and it is a part of the operator framework. Now, why do you use an Operator Lifecycle Manager? To explain it in very simple words, I will give you a very simple analogy. So this is how I understood when I actually first started reading about this. You have operators which manage your application, and you have Operator Lifecycle Manager, which are going to manage all the operators present inside the cluster. So when you have multiple operators inside the cluster, you have a second level of automation, which is the Operator Lifecycle Manager. It does various tasks to help you take care of a particular operator, to make sure the operator is in the condition which you have specified it to be, to perform health checks, to perform upgrades on the operator itself, so on and so forth. So you can consider it to be something which manages operators in your cluster. Now, can Operator Lifecycle Manager be used with Kubernetes? Yes, of course. So Operator Lifecycle Manager has an upstream solution where you can basically take any operator, create catalogs out of it, and use it with Operator Lifecycle Manager. And there is another aspect to it. Here, I am not publicizing Operator SDK. I'm just talking about it in general. So KubeBuilder build projects are similar to Operator SDK build projects, since they seamlessly integrate, and operator built with KubeBuilder can easily interact with an operator built with Operator SDK. Now, the good thing of using Operator SDK is that it provides seamless integration with OLM. So when you use a KubeBuilder, definitely you have to create your own manifest and then make sure that you build catalogs for Operator Lifecycle Manager. Whereas when you use the Operator SDK tool on a KubeBuilder project itself, it makes you easy to build the entire bundle. So bundle is something which is used which is an input to the operator lifecycle manager to manage your operator. So the entire reconciler logic, which you would have written in the project, would be compressed to a bundle, which may contain 4 or 5 files. And this bundle would be given to the OLM. And since all of them are part of operator framework, when you have a kube builder project and you migrate it to Operator SDK, it provides a seamless integration. And if you don't want to use an Operator SDK, you can still create the manifests on your own from a kube builder project and then use it as an input to an operator lifecycle manager. So I also see a comment. Operator is a fancy term for creating CRDs and controller, and you are absolutely right. So operator is just a fancy term. And when you have custom controllers, which are acting upon CRDs and custom resources, you get operators. So that is all an operator is about. And then, do we have any other questions?
The last one seems interesting. The latest one. It's about, is there an IDE that integrates with Operator SDK or Kube Builder directly for ease of development for developers?
Oh, that's actually a great question, and this is something which we should actually work on. So right now we don't have, because Kube Builder and Operator SDK are basically CLI tools, which helps you scaffold. But if you want to integrate this tool into something, into a better IDE like VS Code and have helpful features for that, then definitely. But right now, apart from them being a tool, command line tool, there is no other better way of using them. In the sense, there is no other pretty good dashboard or an IDE which is actually centric on Kube Builder and Operator SDK. So I would like to consider this platform as something where I want to advocate about open source itself. It's not about SDK or Kube Builder, but if you guys are actually interested in getting a deep diving into the Kubernetes era itself, then you can actually look into lots of projects in the Kubernetes org. So it need not be operators specific, or it need not be Kube Builder or controller runtime. So there are various projects in Kubernetes-sigs or in the Kubernetes project itself, and trying them out and having contributors for that would be really, really helpful for all of us. So it will be a good way to gain knowledge, and also it will be a good way to make the project better. For example, this was really a good idea, and we'll really be happy to welcome collaborators working on this particular solution. So does operators controllers come under SIG API machinery? So yes, there is some part of controller runtime and controllers which are part of the SIG API machinery directive. But apart from that, we also have controller related projects in other groups of Kubernetes also. For example, that is client Go, which is widely used, but also we can have an abstraction of client Go and controller runtime.
I have one question. Is there a place or document or resource, anything like that, to think about how do you come up with a design of a CRD? Like I know it's and there are like multiple sources you can look at. Okay, how to design a web app, or how to think about the APIs there. But how do you think about designing a CRD specific to any particular underlying application that you're designing for?
Yes, definitely. So we have extensive documentation on the Kubernetes docs. I think after this talk, that's the first thing I'll do and try to post that in chat. So there is a comparison on when we need to use CRDs and when we need to write our own API server itself. So there is also another option of not using CRDs and writing your own aggregation API server, but then that's a more convoluted option. But as you said, we have, there are lots of documentation. I'll definitely search and post it here, which tells us when and how to define a custom resource and how to write the spec of a custom resource, which is basically using Golang and having a type.go file, defining it, generating a CRD. So there are various abstractions which help us in writing the CRD easier. So you have something known as markers, control agent markers, where you can create a CRD out of a .go file, and writing, specifying the requirements of a CRD in a .go file are more easier because they are more understandable. And once you have the CRD generated, what are the basic keys which you can have, or which you are required to have. So all these things are there in doc. So that's the first thing which I'll do after this. I'll try linking the docs here so that it's pretty useful.
Sure, sounds good. Thanks.
That was a really nice talk, Varsha. Just give me 1 second. Need to check. Yes. Thank you so much, Varsha. This was a really great talk. I'm sure that the audience enjoyed it as well, as we can see from the chat. And also, thank you so much for doing it at this hour. We know it's really late for you. So thank you so much for doing it. And definitely, if you liked Varsha's talk, you can tweet out to her. You can write your gratitude down in the chat. And yes, so that brings us to the end of the first talk. And then the next one is equally, if not more interesting. It's a hands-on demo by Ishan. So before doing that, we would like to take a short 5 minutes break if you wanted. And also, we can take this opportunity. So we had been doing this before the pandemic in our in-person meetups. So what we do is we take a pause, and if some of you and or your companies are hiring, or if you're looking for people to work on Kubernetes related positions or something, you can take a minute to talk about that position and post about it in the chat section, so that it helps the wider community itself. Someone looking for a switch, someone looking for a job, so it really does help. So how you can do it is you can use the raise hand feature. So once you do that, you're visible to us on the participants list. We'll allow you to unmute yourself and you can talk about the roles after that. So I can already see one hand raised. Ravi, there you
go. Hey, thank you so much. Thanks, Prakash and Suresh, for giving this opportunity. This is a great talk, Varsha. We are working on Kubernetes platform on top of AWS with KOps and EKS. We, in the sense, here we are talking about some opportunities that we have at Intuit, where we are building the Kubernetes platform, and we are using this for improving the developer productivity of the teams. And Intuit is recognized as one of the best companies to work for in India for the last 5 years consistently. And we have open sourced a lot of projects on the same lines of this talk, like Argo project is open source from Intuit, and Kiko project and Admiral, they're all open source from Intuit, and they are similarly what we have discussed so far. They are completely based on custom controllers, and we do a lot of work on it and open source so that the wider community uses it. We are also working on multi-cluster connectivity with service mesh using Istio. And we have a lot of openings in Bangalore as well as in US in this area. The scale at which we operate is with more than 250 plus clusters and 7,000 plus namespaces with more than some 20,000 plus pods and other things. So we have a decent amount of scale. So we are looking for people with at least 2+ years of experience and experience with Kubernetes, AWS, and distributed systems is preferred. And please reach out to me. I'll put my details in the description of what we are looking for in this chat. Feel free to reach out to me for any of you are interested in.
Thank you, Ravi. So next up, we have Prithvi. So we go with, okay, one second. Yes, please.
Yeah, hi. Hi everyone. So this is Prithvi from NetApp. I'm working as part of a big data group within NetApp. So NetApp as a storage company, we get like I'll just explain the role we have and then what kind of requirement we have. So NetApp as a storage company, we get lots of petabytes of data from all the systems or the geographically wise. So we work on big data tech stack, and then we have a Kubernetes platform as well to build all the microservices within the big data ecosystem. So basically we use Spark, Kafka, Kubernetes, Python, Java, this kind of tech stack. So if anybody interested in to work in this platform and already have hands-on in these platforms, we do have openings for tech leads and then fresher or 2 years of experience candidates. So you guys can reach out me. I'll send my mail ID in the chat. You guys can reach out me. Thank you.
Awesome. So I think we just have time for one more. We can do the rest of them at the end of the session, right? So Ashish, you're next.
Yeah, thanks Varsha and Suraj. So I was just wondering if we have so many operators already available over like for almost every purpose. So what could be the scenarios? I'm just looking for just one example. So by the way, I'm all the time already using Spark operators or some other operator, but never ever thought of writing my own operator. Maybe never really felt the need for it. But can there be a simple use case which a real-time use case which someone can highlight where they need to write their own operator? Yeah, that's it.
Yeah, as you said, there are lots of operators available in Operator Hub, which do most of your tasks. You have operators available for various databases. As you said, you have operators available for various use cases. But then writing of an operator is based on a business logic, and this business logic can differ based on the needs of a team or an organization. So when I first started with operators, so there'll be various examples, but this is a very basic example which I actually followed when I initially started writing an operator. So this is not a real world use case, but I'll just say it for an example. Is I wanted to write an operator which just looks at the cluster and sends me a message whenever I see that the traffic coming to my application is increasing. So this is not at all a real life use case, but the usage are the reason for writing an operator is completely dependent on the business logic which you have. So you can actually have a look at the operators which are present in Operator Hub. And if you have any specific reason where you have to write a controller loop, then you can use an operator. So you can use an operator for any application which basically has a controller loop.
Yes. So sorry to jump in. We'll do the rest of the jobs and questions at the end of this meetup. I think that brings us to the end of the first session. And now that the break is over, I can bring on the next speaker. So Ishan is our next speaker. He's going to do a hands-on with operators. So Ishan is currently working as a product engineer at Gojek. And spends most of his time, coding and Go and around Kubernetes. So in his spare time, he says he picks up a new sport, or plans solo trips across the country. So that's how he would be spending his weekend if he wasn't with us today. So Ishan, you're next up on stage.
Hey guys, am I audible? Okay.
Yes.
All right, cool. Thanks for the introductions, and also a great session by Varsha. Made a lot of things easier for me. really good explanations about KTS and the controllers in general. So let me just go through in brief that what we are planning to do in the hands-on session. We'll go over using Builder and try to write a very simple controller with a CRD, basically an operator, and it's going to be very simple. So probably it's not going to be a very solving a very complex case, but I think it should give enough idea to people to be able to write controllers for their own use cases. So as part of prerequisites, I would say it would be good if you have a Minikube or a kind or a cluster up in any cloud provider to test your code along with. And the Cube Builder framework itself should be installed. I think I can post a link if people have not already posted it. Let me just, for people who have not installed it yet. Okay, I'll just put the links in the chat. And also, it would be good if you have customize installed. Okay, I think Shlesh is asking that do Docker comes with kind. I'm not sure about it. Docker has a kube cluster that you can use locally, but I'm not sure is it kind or not. I'm not sure about it. Yes, I think somebody pointed out correctly that you will need Docker to use kind. And if not, then you can also use Minikube. That would be fine as well. So probably we can wait a couple of minutes for people who have not installed this, and then we can proceed.
Sure, sounds good.
Yeah.
Folks, if you have any questions with respect to installation of the prerequisites, please ask on the chat.
Okay, I think we can start.
Yes, Ishan. I think we can start.
Yeah, I think. Okay. Let me share my screen. Okay, so I think the screen is visible, and is the font size okay for everybody?
Looks good, I think. Yeah.
Okay, cool. Okay, so I have just a cluster here, local kind cluster, and just a bare minimum thing. And what we are going to do is create a cloud native version of the AT command that comes with Unix. So you can read at the man pages. Basically, all it says is that you give a time and a command that needs to be run, and it at that specified time, AT would run your command. So in terms of Kubernetes, what we are going to do is our CRD would specify two things, uh, two fields in the spec, basically. One would be your timestamp string, and the second would be the command that needs to be run. The controller will keep watching for that time, and once the time comes, it spawns a new pod, and the command that you specify in the CRD is going to be run inside that pod. Uh, so it's a fairly simple thing. I mean, usually people won't write a controller for this, but it should allow people to understand how writing a controller is basically done on the lower level. So we'll be using a cube builder for this. So I'll start this project from scratch. There's nothing currently apart from my kind configuration. So I'll just do a go mod inet here, and let's name it there we go. Just an empty go mod file, and let's initialize our cube builder project. Builder 8. Oh, sorry, I need to do an inet first and give a domain. So domain can be something of your choice. For example, like Istio uses an istio.io. It can be your company domain or your project name or whatever. So I'll just use domain here. So what's going to happen is Cube Builder is going to initialize the project and generate a lot of scaffolding for us. So this will be very similar to something like people familiar with Rails or Django, writing a lot of scaffolding and helper things around for us to use. So we can just show it here. So we started with just a go.mod, but now Cube Builder has created a lot of things for us. We'll go over this mostly, but mainly the main entry point for us would be this makefile. A lot of targets here that can be used, like in terms of cube builder, they will allow us to do a lot of controlling and helper method generations and all those kind of things from here, automate a lot of tasks for us. And another thing that we might want to look at would be so there's not much here. Most of some scaffoldings here around using customization. This would basically help us when we try to deploy our controller packaged as a Kubernetes deployment. It will also help us creating. So it has also written a Docker file for us. We don't need to write that ourselves. So all the packaging and stuff would go in here. And yeah, so right now there's nothing related to controller here. So what we can do is ask KubeBuilder to generate some scaffolding for us to start filling up our controller logic. So basically it would be like we'll start with a CRD and a corresponding controller. We can start with a very basic version v1 alpha 1 and start filling up the details of our CRD, and then install the custom resources into the cluster so that the cluster recognizes our CRD first of all, and then we look into the controller code and how the events related to CRDs are reaching the controller, and then we can start acting on those events. That when a CRD is created or modified or deleted, the controller gets called, and then we start to process those events in the controller. So just build create API. So we can give it a group, which is that. And the version is an initial version. So we'll just go with v1 alpha 1, and the kind can be just 80 because that's what we are trying to build here. So it's asking us to whether we want to create a resource or just a controller. So sometimes when you're writing a controller that just watches some inbuilt objects, let's say pod creation events or deployments events, then you don't need to write an explicit resource. So you can just say no here, and you can just write a controller that would respond to events happening around, let's say, a deployment, right? Whereas when you have something more custom of this sort, okay, is there a question? Just a minute. Okay, yeah. So if in case we are writing a more custom thing around CRD, then we would like the KubeBuilder framework to generate a resource for us. I'll just answer yes here. And we of course need a controller. So we answer yes. And it's going to generate a scaffolding for us. Pretty helpful. And meanwhile, let me just tell you that both, I think, KubeBuilder and Operator SDK are just wrapper frameworks around controller runtime. So nothing stops you to just use controller runtime directly and write your controller. It's just that you'll have to write a lot of the things around config and RBACs and all these kind of things yourself, whereas the framework here would just take care for you. But you can always, because the whole interface is modeled around makefile, so you can always break out of the framework itself. If you want to customize it, it's very easy to customize it according to your use cases. So I'll just refresh the ID here. Okay, so we just saw, after running this, what we just saw is that we have an API, new package API generated for us, and a controllers package generated for us. And there's also main.go file, which is already there. So I'll just go through the main.go and try to explain a little bit about it. So let's start with the main function. So here we're just setting up some environment variables, a leader election. We can go through it later on. And the main thing over here is the controller manager. So what you do is when you write controllers, you can have a single deployment having and watching multiple different controllers. So like right now we have just created one controller 80, but we can also create more controllers as part of this code itself. Okay, and they all register to this controller.manager, which is the new manager, that object that we're creating here. And then what it is doing is that on line 69, you can see that it imported the 80 reconciler, which is defined in the controllers package for us. And it is registering it with the manager object. More controllers that we create in this particular code will also register with the same manager. Okay, and it's just that we register that here and we start the manager itself, and that's all there is in the main.go. Next, I would want to show you guys what's there in the API. That's where the main thing begins. So we have 3 files here: 80 types, group version info, and ZZ generated deep copy. So 80 types.go is basically the file which is base for our CRD. Right now it's just having a placeholder foo thing inside the spec. So this is our main 80 struct. This is basically a Kubernetes object, which has a type meta and an object meta. Sorry, on line 45, you can see this is the type meta, this is the object meta, which are from meta v1, which is part of every Kubernetes object. And the spec holds the 80 spec, and the status holds the 80 status. The spec is where we can define what fields go inside the spec fields of our CRD. And the status is where where the controller can report to the users or the Kubernetes administrator that what is the current status of the CRD. And so basically the spec is the desired state versus the status is the current status of that resource that the controller is working on. So so for the first thing that we would want to do here is we have to explicitly go and enable the status sub resource, and we can do that by just adding a generated tag that is used by KubeBuilder here. So KubeBuilder internally uses a library called controller gen that uses these comment tags to take hints to how to generate and which kind of scaffoldings to generate. So what we can do is resource. So this should work for us. And okay. Also, I think we have samples. So this is a sample YAML of our CRD that has been generated. So as you can see, I'll split the screen and just try to show. As you can see right now, so the API version and kind fields are coming from your type meta and object meta, and also the metadata thing, and the 80 spec is basically what's generating the like currently there's just foo there, and you have the foo field as an example. So what we would want to do here is that let's just define how our spec should look like in YAML. So we want two things. One would be a schedule, when to schedule a pod, when to run the pod for us, and the command which we want to run inside that pod. So just go and add that. So let's just put some date here. I have a copy date. I'll just copy paste it and you can edit it. Okay, we can change the date to 2021. What's the date today? It's 27th March. Okay, so 27 here. Let's put 13 maybe. What's the time? Yeah, 13 should be good. 13:00. Okay. And the next thing that we want here is a command. So let's echo something, just echo. And we can just get rid of foo. We don't need this. And basically, so this is the lower part of the editor shows that what we want our CRD to look like, and this is how we would want our Go code to reflect as well. So what I'm going to do is I'm going to remove this placeholder thing from here. The 80 types.go. This, yeah. And we'll define these two fields, which is schedule, which is a type of string, and we'll say JSON schedule, and we also need a command, which is also a string, and a JSON with empty. And all right, so this is about the spec, and the next part is about the status. So if you see our AT resource itself defined two major things. We just defined our spec here. We also want to define what goes in the status. So in case of pods, we can have kind of just 3 statuses right now. You can always change this. So I'm just going to define those status as strings over here. So like we'll define the phases basically. So we'll say phase pending, something like this, and it is just pending, and phase running would be reporting running, and phase done should be just done, and inside the status we would say something like we have a phase which is a string, and it's just JSON. Empty. All right, and I think this should be good enough to define our CRD itself. Best way to test it is just use the framework to generate. So I'll just open the make file here. So there is a manifest. Yes, where's that? Okay, so as you can see over here, we have the make manifest target, which is going to use the controller gen itself and going to regenerate all the CRDs in the folder that we have here, config CRD basis, which is the same as this one, config CRD and basis. So config CRD. So we don't have basis yet because we have never run this command up till now. So we'll just go ahead and run make manifest and okay. So let's see what did it generate for us. So we have a basis folder here and it generated the cnat.ishankhare.dev underscore your resource in a plural .yaml. And this is the custom resource file that it generated for us. Just enlarge it. So this is basically the custom resource definition that it has generated. And what's going to say, like this CRD definition itself is going to allow Kubernetes to understand the YAML that we have here. So when I do something like for this particular file over here, like kind 80, if I do a kubectl apply f on this file, Kubernetes will be able to understand that, yes, okay, this is what 80 means. Okay, and this validation open API v3 schema can be used, like these fields can be used to write some additional validations and helpers and documentation around the fields that we have in spec. So if you run the kubectl explain or those kind of commands, you can specify those kind of help and other kind of validations here, and people can just do a kubectl explain 80 and this it will report over here. So just like if you say k explain deploy, so it would start explaining you. This is the built-in deployments. So in the same way, you can write using the Open API spec, you can write description and what are the, okay, somebody is getting errors. Okay, imported from implicitly required module to add machine requirements to run to go. Okay. Okay, not sure which version of Go you are using. Okay, I'll just open the go.mod in my. So I have Go 1.13 and this is what I have over here. Akshay, can you check the versions? I think it's v1.11.01. Are you using Go mod or are you using the package thing with the Go pack thing? Okay. Is implicitly imported. I don't see a Gink Go in your go.mod, right? Mhm. All right. It might be because of a difference in a cube builder binary versions that we have. Maybe some folks installed a newer version while I have an older version. So I'll just do a version here. So my cube builder version currently is 2.3.1. People might have a little slightly different version, and maybe that can be a cause that it did not resolve all the dependencies properly. Yeah, I think Amit has posted something. So okay. Uh, Please try what Amit posted. Try to install git.go and all those libraries with git go. We can stop for a couple of minutes and you can then catch up with us. Yeah, I I think I have an older version here. All right, I think we're good to go, Akshay. Okay, cool. So as I explained, this is the custom resource definition that would allow Kubernetes to understand what that AT kind means. And the next thing that we need to do is just install these CRDs and other things into the cluster itself. And so if you currently say k explain AT, Kubernetes is just going to complain that does not understand what AT is. So right now, let's say we do make install, and what it's going to do is you can see that in fact in your make file, all it's going to do is um, yeah. So it's going to call the manifest thing for you, and it's going to use customize and combine all the things inside your config CRDs using customize and do a kubectl apply F. And it reports that it created a custom resource definition for that generated CRD that we have. And if we say k explain AT now, it would at least say that we have not added a description and everything, but it recognizes what an AT thing is. Okay, so looks good so far. I mean, we have been able to tell Kubernetes that what our resource or our kind basically means. So Kubernetes should be able to uh, uh, create a resource, at least for us, that we see here in this YAML. So the samples YAML that we edited with our schedule and command, if we go ahead and apply this now, Kubernetes should be able to understand and create an object for us. So let's try to do that. Okay, apply yes, config slash samples slash AT sample. I've seen that. Okay. Okay. So Kubernetes reports that it has created this. So let's try to say kubectl get AT. All right, so it says that it has one object whose name is AT sample, which matches with our object created 13 seconds ago. We can see in detail what is there. So let's enlarge this. So a lot of gibberish, but most important part is the spec. So we have echo command here, and the schedule that we wanted is there. And yeah, this looks good. So now we are able to tell Kubernetes what our resource looks like and what do they mean. Okay, oh, I'm sorry, I didn't pay attention to Ashish's chat. Okay, he's on Windows, and there's some issue regarding installing KubeBuilder on Windows.
I think they stopped shipping the binary for some reason.
Oh.
I don't see it on the assets on the releases page of
Okay.
Kubernetes as well.
So Ashish, maybe you would want to use some there's an Ubuntu subsystem.
Or Ashish, if you have Minikube running, maybe try SSHing into the machine and then doing all this there. Maybe that can work.
Can be, or maybe spin up a Ubuntu cluster. I mean, an Ubuntu VM with your VirtualBox. Okay, am I going too fast, or should we wait a little bit for folks to catch up? Please feel free to pause me in that case. I think we're good to move on. First, instructions for installation of Go and KubeBuilder on Ubuntu. Okay. I think for Go, it's just from the official website. That should be enough. And I don't know, like if you can, Naveen, you can post what errors you are experiencing. That would be more helpful. People can help you out. Okay. Okay, so meanwhile, I'll just want to focus a little bit on the main.go again and go over and explain a little bit about scheme. So we have a runtime.scheme here. Okay, and what we do is we use the client go scheme, which is imported here from client go itself. So this would have all the schemes of built-in Kubernetes objects, and one is from our own CRD package. Okay, so for the for our package that we generated here, the CRD package, we also have add to scheme here. What it basically does is I can. So what it's going to tell Kubernetes is that basically which group and which version these objects belong to. And all this is generated for us by the scaffolding itself. So the pack is created and like taking care for in those cases. So yeah, So the scheme object, so we register two schemes, the built-in scheme and the scheme for our CRD. And then the scheme itself is used later on into and provided into the manager itself. And when you go ahead and when we go ahead and look into the reconciler itself, what we are going to do is we are instantiating the reconciler with that same scheme. So the reconciler would get to know the scheme and the things inside that. Okay, there are a few people. I think we should go ahead with diving into the controller side now. Please interrupt me if I'm going very fast. Okay. So up till now, we were just talking about the resources and how we can define the fields in the resources and generate the corresponding definition for our custom resource and installing it and making our cluster aware of our kind. Now that we have it and we have the resource here as we saw, what is there? So this was the resource that we had. It is created. So now we would want to dive into the controller part of the things where we say that what needs to be done when a particular thing, like anything, any event happens for our given type. So KubeBuilder created a controllers package for us. In the controllers directory, we have two things. One is for the test and the other one is, of course, the atcontroller.go. So let's look into what it is soon. I'll just close this one. Okay. So as I already explained that it is entirely or very much around built around the controller runtime library and also uses some bit from API machinery. So uh, we're just writing some scaffolding on top of things provided by these libraries from KTS already. So right now, all it needs is basically a type, which is at.reconciler. And if I open the code dev, show you about this post. Just give me a moment. I'll also post the documentation links, which might be helpful for people. Okay, so what is required is basically the type which you are specifying here needs to just implement the reconcile interface that the library defines. I'll just post that link here in the chat. Right here. So if you go to the link, it will tell you that the reconciler is an interface defined inside the controller runtime library. And all it says is that you need to define a function called reconcile with with two methods. One would be a context and the second would be a request. And in my case, as previously pointed out, that I am using a slightly older version, so I don't have a context here. Instead, I just have a request, but the newer versions would be defining something like context dot context here as the first argument. So if you have a context dot context, that's totally fine. Otherwise, all I'm going to do is I'm going to build a context here on the first line of the function. So that's going to be fine. Okay, Naveen is still experiencing some issues with installation, I guess. I think he's getting a permission denied issue. Maybe try to do a sudo on it. Okay, wait. I think he tried an RMRF on user local go. Maybe that is causing him permission denied errors. Oh no. Okay. You would want to probably, yes, either break that into two commands or as Suraj pointed out. Yeah, I'll do that. Okay. All right. So what's going to happen is that if I open, so in the main.go, we are creating a reconciler and registering it with our manager using setup with manager function, which you can see right here. So we created an object of type 80 reconciler, which is defined from 31 to 35 here. Right here, as you can see, and we initialized the fields client log and scheme with get client log and get scheme, and we pass in a manager, and we create a new controller managed by for with an instance of our type, and we complete and return from it. Okay, so this is basically plugging in our controller with the manager object here. And this would basically mean that, if we have a very bare bones reconciler, and I think when Varsha was explaining the details of the controllers themselves, we had a lot of components. There were shared informers and there was a work queue, and this was the part of the loop that gets called for every event that happens on our CRD. So every time anybody goes and creates a CRD or updates a value in the CRD, deletes it, anything. So this function is going to get triggered. So this is where we start writing our business logic. Are there any questions so far? No, right? Okay. So, all right. So, let's just start with something very simple. So we will just use X, and let's call it logger and let's just first of all logger.info, just print something that okay, styling So this should just give us, okay, sorry, my bad. And we are not using CTX yet, so let's just okay. So all I've done is right now I've just added a debug method. I mean a debug call that should just print a log message. And what we can do is that we can try to run the controller itself and see if we are getting the events for our controller, for our object or not. So all we need to do is call make run here, and it's going to use the local context, the current context in your kubectl. So just make sure you're not pointing to any of your upstream Kubernetes cluster, and just say just checking. So it's currently just pointing to my local current cluster. I'm just going to say make run. So right now, make run is not going to deploy anything to our cluster. All it's going to do is that use the context and the credentials in the context and connect to the Kube API server running in that cluster. You're not going to deploy anything right now inside the cluster. Okay, so it just runs go run main.go. It is going to set up our manager, create a controller instance, and start the manager itself. We just put it on full screen and we say that. Okay, so it basically started a controller, started a worker. This is taken care by the framework itself. And the first event that we see, which we added in the code, is reconciling on AT resource. And this is the method that we basically added there, and we are seeing. So basically we have one object, and let's see what happens if we try to delete it. We should get another event. So okay, delete AT. Okay, so if I delete it, we should immediately got another event. Right now, it's just a generic event that just tells that okay, we got some event. We're not able to distinguish what kind of event it is, and okay, that's good. Naveen has got go installed. Good to go, right? Um, right. So recreate the object, and you can see that it's responding very well, the controller, um, to our events for the CRD. So next thing that we want to do is, so right now we every time we get an event for our CRD, we get something of the event is of type control.ctrl.request. If we see what's there in the request, it's basically a reconcile.request, which says that it just has one thing, which is namespace name. And if you go into the details of namespace name, it will just be a namespace and the name. Okay. But while initializing Cube Builder, I get this. Scope path cannot create directories or such file or directory. Okay. Now we are still experiencing something with Cube Builder. Folks, anybody using Ubuntu can help out Naveen here. He's facing some issues. Okay. So yeah. So our request just holds two things here: the namespace and the name that our CRD got created in. So we don't have our entire CRD itself. The request just tells us that this is the name and this is the namespace where something was done to the CRD, as it got created, deleted, edited, whatever. Okay, so what we need to do is we need to fetch the CRD itself, the entire thing. So for that, what we can do is we can create an empty object first, which is instance, let's say, and we create an empty object of ampersand v1 alpha 1 dot empty, okay, and use this empty object to query from the API server to dot get and dot get. If you see in the definition, it retrieves an object for the given object key from the Kubernetes cluster. So just get it using CTX, and if it takes a CTX, it takes a CTX, and it takes so for the object key we have req dot namespace name, and we want the result to be stored in the empty instance that we just created. Just CTX here. All right, and then we say error in case we get an error. It's not equal to nil. So there can be a few scenarios. One basic one can be that the event that we receive would be because of a delete event. So in that case, what will happen is that when the reconciler function gets called, it's actually a delete event and there is no more that resource present. Okay, and then we on line 46 we try to get that resource, and since it's already deleted, it's going to give us an error. In that case, we can say okay, somebody okay, errors dot is not found. So if the error is of this type, then we can just say return dot result nil, and if we want, we can also do a dot info, and info can tell object already deleted maybe. Right. So with the first case, now after this, we can be sure if there's no error, then the instance variable now holds the actual data of our CRD. So the first thing is, since we created, if I show you the 80 sample that we had, sample, okay. Sample. So here we have only defined the spec. We have not defined anything related to status. So the initial state of the object would be that the status dot phase would not be set to anything. So we can check that instance dot status dot phase is double equal to null string. Then we can set it explicitly to instance dot status dot phase is equal to that dot phase pending, because still needs to be processed, and the next thing that we would want to do is once we have defined this, now in case there's an event after this where the status has changed, We have two more statuses defined in the AT_times. So see, we have pending goes to running, and running goes to done. So what we can do is we can just have a switch case, switch instance dot status face. Okay. And we can start processing each case by case now. Okay, so case also working fine. All right, Naveen, good. It's good. So please, I understand Naveen is because of some errors that he faced. He might be a little behind us, so please feel free to ask questions regarding steps we have already been through. We'll answer that on the chat. Is there another question? What's the next step after make run? Right now, there's no step after make run. We are still, we just did a make run here, which is currently executing, and we are just adding our logic here into the atcontroller.go file that you would find under controllers. And all we have done right now is just this that you see, the highlighted part. We have added a logger. I mean, logger was already there. We just named it, and we are querying from the API server, the resource itself, and we are now basically case by case trying to process the resource states. So this is the first case where we say that alpha1 dot phase pending. So in case of pending, it's log first. Logger. Oh, you can say phase pending, and next we would want to do is something that basically tells us that that allows us to calculate a diff between the actual time we gave into our CRD at the time at which we want to run our controller versus the current time. So I'll just what I'll do is I'll just add a new directory here with kg slash something like schedule maybe. U slash outcome, something like this. So okay, here we are. You see this package here with div.go. So this is where we would want to implement our logic for processing of the time comparison. So I'll just quickly write input time. Feel free to ask any questions regarding this. So I'll define a function time to use and string, and it returns a duration of with current time would be time dot now correct. So people who are not familiar with Go way of processing time, so it's a little different than strf time and other time formats. So you can look up that in the Go documentation. It is basically something like okay, I'll post that link as well. So 2006, something like this. You have to give an year, month, day, and you can say time zone, and then time is 15 or 04. 5, 3. So anybody wants to look this up? Let me just have it will run the command define. Can you really explain exactly the end result after the yeah? So I think to answer Naveen's question, like we'll give it a time and we'll give it a command as part of our CRD spec, and the controller will keep watching it, and when the time comes it's going to schedule a pod and run the given command inside that pod. That is the end result that's going to happen. Yeah, that's it. Okay, and so now we can close to time.
Hey, Ishan.
Yeah.
Once we're done with the immediate next part, can we just take a 5 minutes break?
Yeah, sure. I know
Grab
it's
some coffee.
going to get a long, it's becoming a long session. Yeah. Sure.
And yes, so that will happen.
Yeah, I'll just finish this section and then we can take a break.
Sure.
Right. So we do okay. So we pass the current time, and I mean we give the layout, and based on that we pass the scheduled string that we have given in the CRD. And now that we have the scheduled time as a time.time object, what we can do is we can do a subtract with the current time that we have here in now. So what we can do is time dot subtract. So all it does is returns the duration, and let me just say now, and all right. So what we can do now is in the first part of our phase pending thing, we can say the diff error is equal to u dot time until schedule, and we can say instance dot spec dot schedule. This is what goes in as an input to our function, and returns, I think yeah, not used. Okay, and if error is not equal to nil, so this can be because you have a wrong, maybe the spec, the schedule string in the CRD is not of the right layout or format, and this time dot pass errors out. So you would see an error return from here. So in that case, we can just say dot error and a message that error passing field, error passing schedule. And what we're going to do is return. So as you can see, this function reconcile itself returns a controller.result and an error. So in this case, we don't have any result right now. So we can say controller.an empty result. But if you return an error instead of a nil, what's going to happen is the controller, basically this particular event is going to be requeued and uh, processed again. What we can do is instead of directly requeuing it and hitting it again and again, what we can do is there's also an option in the result where we can say requeue after and give a time dot duration so that we can get some buffering and we don't experience thrashing kind of scenarios. But we'll not do that right now. Let's just keep things simple. This is basically the diff, and if diff is greater than 0, then what we do is it basically means that it's not yet time to execute the command. We have to wait. So what we do is we requeue the request, but what we can do is that since we already know the diff here, that this many seconds are remaining before hitting this time. So instead of requeuing this directly and then again hitting it again and again, what we can do is we can actually give sorry. Result, and we can actually give it a requeue after, and in requeue after we can use the diff that we had multiplied by time dot second. Okay, and there is no error, so return a nil. So what this is going to do is it's just going to requeue this particular event back into the work queue, but that is not going to be processed by our reconciler until that requeue after event. Okay, so like if there's still 10 seconds left before we hit that time, so this event is not going to come up again or get requeued again before those 10 seconds. If we don't use this, then what we'll see is that this will we'll see it coming again and again, right up till it's not processed. So that's going to save us some processing logic and not hog our controller out. So I think this should be good enough, and we can take a break and then we can see how we can process the other phases and how we can complete this whole controller. Yes, I think Nabran has also posted the link for the repo that can also be used for just going through this if anybody is going through any errors.
So we can take a 5 minutes break, right?
Yeah, definitely. Let's just take a break here.
So folks, if you would like to take coffee or whatever, this is the time. Also, like we did in the last break, maybe if folks wants to like talk about their job openings, please go ahead.
You can raise your hand and we can ask you to unmute yourself.
Hey, again, this is Ravi. I just wanted to, bring it up again. Intuit India is looking to hire folks in Kubernetes and AWS or ACP, GCP or Azure platforms, whoever have experience in distributed systems and Kubernetes with minimum 2+ years of experience. Please feel free to reach out. I'm putting the message in the Zoom chat again. Thank you. Thanks, Prakash and Suraj.
Navarun, you want to go next?
Hey, sorry, what's this regarding?
Or you wanted to say something about?
Oh yes, sorry. Sorry, I was just looking at something else. So I just wanted to give a quick shout out. So my team at VMware is looking for people who want to work on upstream Kubernetes or the downstream Tanzu Kubernetes grid team. Giving a quick short blurb about Tanzu Kubernetes grid. It's basically a Kubernetes runtime where you have consistency over multi-cloud environments, be it on-prem, be it on private cloud, or be it like public cloud or on edge deployments. It also integrates well with our existing ecosystem. So if you like to work on such challenges, ping me on Twitter or Kubernetes Slack. I am Navarun on Kubernetes Slack. So I will also give some links on the chat in a few minutes if you're interested. So that's all.
Anybody else wants to do a hiring pitch? Please go ahead. We still have 2 minutes.
Ishan, are you back?
Okay, yeah. We can start when.
Yeah,
Yep.
whenever you're ready.
Shall we start? Continue? Yep.
Yes.
Okay, cool. Okay. Okay, screen is visible, right?
Yes, we can see it.
Oh, okay, cool. Okay, so this is where we left. So basically, either the diff was greater than 0, and in that case, we requeue up till a later point, and otherwise, what we say is that we just log the message that we have hit the time and we transition the state. Okay. Uh, and mind you, this is the local, like in-memory object that we have. We have still not, like we have just modified the instance variable. We have not propagated this change to K8s yet. The API server, we have not issued a request to API server yet to register this upgrade. This is just a local copy, in-memory copy of the instance that we have where we are updating the phase right now. We'll go ahead and do that in a moment. Uh, so up till now, what we are doing is that we recognize the pending phase and we have transitioned to a running phase. Now, what do you do in that case is basically what we're going to handle now. So case one dot status is running. Okay, so let's just see. All right, so the first thing is we can first of all query if the pod is running or not. So query to 10% one dot already running or not, and we can check that. Right. And we can also check start is found. Then all we can say is that pod does not exist. So we need to create one. And for that, what we need to do is R. So R is basically a reconciler object, and there's a embedded client over here. So all the methods inside the client are now directly present under the reconciler. That's why I'm able to directly call r dot create and all these methods. Basically, they're coming in from the client, which is the controller runtime client, by the way, just slightly different from your client Go. And yeah, so far any questions? Just can wrap up by 2:15. We are overshooting. Just want to get an idea. I think yeah, I think 2:15. Okay, I'll try to wrap this up more quickly, Prakash. Okay. CTX. Path. So is not equal to nil. Feel free to ask questions in the chat or raise hands. Otherwise, we have successfully created a pod. So what we do here is give it a name and we give pod this. And, okay. So just one case, and another thing is else if it's not equal to 9, but it's not a create a pod. And, just say yeah, it should be good. And another thing can be if is double equal to what is the vim config you are using for editing the file. So there's a Go plugin called Vim Go that should be good enough to get you set up. Let's go. Is equal to core one dot failed pod failed, or if it can be status dot freeze code one or exceeded. In that case, what's going to happen is pod has probably finished, or I'm just adding a few comments just to for the people who are terminated. Get done with this, and instance dot status phase. We transition to these one dot is done, right? And last case can be else, which is basically we don't need to requeue this. The pod changes will automatically trigger the right things for us. So result and here this should be good. So we have a code here. Switch start inputs. Controller. That's it. And here. So far we have this, and we still don't have the pod object here. For that, what we are going to do is we are going to just create another package which will generate the pod scaffolding for us. So we'll just call it on slash pod.go. And spawn will take care of spawning the pod for us. Right. So it takes in our resource, our custom resource 80 as an argument, and it will return a core v1 dot pod object. And yes, let me import all the things required here. I'll just do a quick copy paste from else. So if you need, we can add labels. Just identify some this, and then we just go ahead and return a pod with the right things filled up. Dot pod. So just constructing the object meta here should be meta v1 dot meta. The name would be the name specified in our custom resource. The namespace will also be same as that. And the labels will be exactly same as and coming to the spec, what we can do is core v1 dot pod spec and check pod spec. We just define one container. Containers usually in any of containers. Core v1 and inside this container object, the name container object. So we'll just use a simple busybox container. That's moved. And the image is also busy box, and the command. Since we are giving the whole command in our spec as a single string, whereas the command would ideally want it to be split with spaces, so we can say string start split spec dot and split at spaces, and after this, we can set a restart policy. One dot restart policy on field. What are we missing? Okay, commas. Okay. Okay. So missing meta v1. Okay. Import from meta v1. So all right, cool. So this looks good now. Switch back to our controller file. Okay, I think there's no question so far. Yeah. Cool. Yeah. So we needed to create the pod itself. So what we're going to do is we're going to use the same function that we just wrote in that package. So we can say spawn dot all for here. Okay, just all right. Yeah, so we got a pod, and one thing that we would want to do is set ownership for this newly created pod. So for that, what we are going to do is we can say dot set reference, and on the instance, yeah, instance, and pod is the controlled object, and scheme is basically what helps us identify which version kind thing is which. It's not in, issue. All right. Now that we have our pod ready, all we need to do is just handle the last case where we have the a pod phase done. So I'm just going quickly around this. Dot done, and we can just log here. And feel free to ask any questions because I'm kind of hurrying up on this just for the sake of time. So if anybody's behind, please turn result and in the default case, we might say no operation basically maybe push all right. So now a common operation after all this is that, as you can see on line 1110, we change the pod status in each of the switch cases. Over here as well, we're transitioning the phase to running. Over here, we're transitioning the phase to done. So this was all done on the local object, which was the instance thing, but we haven't communicated this update back to the Kubernetes API server, which would update that in the etcd and again generate a new event for that. So to do that, we have commented out this code status dot update, because we are just updating the status part and not the spec itself. So all we are saying is ctx comma instance. So whatever update was there is going to be done here. It's not equal to nil. Okay. So and otherwise we have this. One last thing is that back here, what we are saying is we create a controller which is managed by a manager, and the controller is for this particular kind, which is our crd.at, and we complete that. So complete is like it will just do the entire thing at the end. And what we also want to set is that all the pods that get created as part of our controller's logic, that whenever we hit the time, we create a pod. Those pods are owned by our controller, and for all those pods, we want events to come to our controller as well. So for that, we have something called owns. Okay, and in owns we can say ampersand core v1 dot pod. So what this is going to do is it's going to allow all pod creation updation events to come to our controller, but only those pods which are owned by our controller, and that we have set here, which says the controller reference. So basically only those pods which have the controller reference attached to our controller will receive events for those pods only. Okay, and I think this should be good enough. What we can do is we can try running make again and recompile the app. Hope I have not missed anything and should run. Oh, okay. Did miss something. Hard. Go. Define meta v1. Oh, okay. We have not defined. We have an import basically. Let me just. Please show setup with manager function. I missed the owns part. Yeah, sure. This way. I'll show you the import. So yeah, right here. So I've just defined this owns function, which tells that our controller owns the pods that are created by it. Is it good, Amit? Yeah. All right, cool. Works. All right. Picture is running. Reconciling the source. Okay, we have a phase pending, which not transitioning to the next phase. Why is that? Transition it to is running. Oh, okay, I see. So the thing is that the time is not yet. So we must have the timestamp that we provided in the CRD is probably not good. Also, let me just add a mark here. Info, not yet done. This should tell us that. Okay. So what have we done? 327. This is 02. Okay, yeah, it's because the spec says 07, 46, 44, something like that, whereas it's just 2. So let's try to make it simple. 2 is like 14. Oh no, I'm in the wrong place. Oh, yes. This is the place. This should work actually. Yes. Did I write the wrong? Is already work? Oh yes, I have written the wrong. Sorry for this. Now it should work for the, because we have given 13, which is already past our time. So it should execute. Oh, yeah. Okay. So reconciling, pending, it's time, then it transitioned to phase running, then it says successfully created a pod, then phase was running, then container terminated, phase is done. So it did create a pod for us. So let's see, get pod. Okay, so we see a pod that is already completed. And if we try to get logs for logs for 80, hello Kubernetes, that was the command that we gave, I think, in our sample. Yeah, so we gave echo hello Kubernetes, so it executed that command in that pod and basically exited. So yes, Prakash, I think the demo is done here. I mean, this was mostly what I had. We were able to create this through a controller, and now I would be happy to take any questions. I think we are almost on time.
Yes, thank you so much, Ishan. So this was a great session. I'm sure that the people who are working along with you, they got to learn a lot. And of course, they can post questions. I think you've covered most of the questions posted in the chat. And if you have any more questions, actually, you can get in touch with Ishan as well through his, or get in touch with him online, maybe on Twitter or the Kubernetes Slack. So Ishan, if you could post those links so that our audience knows how to reach out to you.
Oh yeah, sure.
Great.
So also this this whole exercise that we just went through, I've explained this as a blog post as well. So I'll post that link here as well. And you can reach out to me on Twitter. I'll just post my Twitter handle as well, folks.
Well, thank you so much, Suraj. I think Suraj posted.
Yeah, the Slack as well. That's fine.
So that brings us to the end of the Kubernetes March 2021 meetup. I hope all of you learned a bit, had something to take back from this meetup, right? Ishan, it would be great help to us if you can give us the link to your slide demo or any other links.
Oh yeah, sure.
Right?
So as I've already posted the blog post there, the link to the blog post, I'll also post a link to the repo of the same thing.
Yes, and anything that you think that will help the audience understand it better.
Oh, sure.
Yeah, any more reference links, that would be great.
Yeah.
And we'll also get the link to Varsha's slides, and we'll post it on our Kubernetes Twitter and the meetup pages. Yeah. So also, if you're not yet on Slack, we encourage people to join the Kubernetes Slack, the official Kubernetes Slack. You'll find most of us there, and you can at any point ping us over there and get in touch with us. You can ask any kind of questions over there. The India specific channels are in -dev, in -events, and in -users. So no question is stupid. You have any kind of questions you can ask over there, and people are very friendly and ready to help you out. And also, if you have any feedback that you want to give us, you can give us the feedback at the end of this meetup, right? So we will let you unmute yourself. You can raise your hand and you can give us the feedback. You can follow us on Twitter. We are our Twitter handle is K8SBLR, right? So also we do this meetup every month, once every month. So in case you want to present a talk of yours, you can get in touch with either of us, or just tweet to us at K8SBLR Twitter handle, or through any channel, the Kubernetes Slack. You can get in touch with us and let us know, and we can definitely schedule your talks in one of the upcoming meetups. And if you like this video, it's there on YouTube. If you think this can help someone, you can like it and share it with people who could not attend this meetup, right? Maybe colleagues, maybe people in other time zones, or people you think this meetup and the content in this can help. You can go ahead and share this in all those channels, right? So Suraj, do you have anything to add?
No, just my gratitude to the speakers and attendees.
Do we go for the open session for the feedbacks and everything? So yes, folks, if you have any feedback,